Hey everyone and welcome. Today, we're cracking open the engine of Node.js, the event loop. If you've ever been baffled by how Node can juggle thousands of connections all at once on a single thread, well, you're in the right place. Let's dive in. Take a look at this. Seems pretty simple, right? A few logs, a timeout set to 0, something called setImmediate, a next tick, and a promise. Now, you'd think it would just run straight from top to bottom, but the way Node actually runs this code reveals everything about its secret sauce.
So, what do you think? What's the final output in the console? Go ahead, pause, and take a guess. Seriously. Because figuring this out is the key to mastering Node's asynchronous nature. And by the end of this, you'll be able to solve this kind of puzzle, no problem.
So here's how we're going to break this down. First, we'll look at the single-threaded puzzle. Then, we'll meet the engine that makes it all work. We'll take a tour of the event loop itself, discover a special VIP lane for certain tasks, and finally, we'll learn the most important rule in all of Node: don't block the loop. Okay, first things first, let's get our heads around the central idea that makes Node.js so different. Right, so here's the big idea. All of your JavaScript, every single line, runs on one main thread. Now, in the old days of web servers, a new connection often meant a whole new thread. You can imagine how that got heavy and expensive really fast. But Node's single thread has a secret weapon that lets it handle a ton of stuff at once without breaking a sweat. And that is the million-dollar question, isn't it? If there's only one chef in the kitchen, our main thread, how on earth does it handle 1,000 different orders coming in without bringing the whole restaurant to a standstill? Well, the magic isn't in the JavaScript itself. It's in what's happening underneath. So let's pull back the curtain and meet the real workhorse of Node.js. Meet libuv. This is a powerful C library that is the absolute heart of Node. It's what gives Node its async powers, the ability to kick off a task like a database query or reading a file, and then immediately move on to something else without waiting. Think of your JavaScript as the master chef. libuv is like the world's most efficient head waiter. The chef gives an order to the waiter who takes it and handles all the legwork, only coming back when the dish is actually ready. This frees the chef up to just keep cooking, one dish after another. Now, that head waiter, libuv, doesn't always work alone. You see, some operations, like working with the file system, are just slow and blocking by nature. For those, libuv has a small team of helpers called the thread pool. So when you ask Node to read a file, it just hands that job off to one of these helpers. That helper does the slow work of talking to the hard drive, and once it's done, it tells the head waiter, who then puts your callback function in line to be run by the chef. And how many of these helpers are on the team by default? 100? 50? Nope. It's 4. Just 4 threads, and that is why you have to be so careful. If you give all 4 of them some heavy, complex math problem to solve, you've tied up your entire crew. Nothing else that needs them, like other file operations, can get done. Okay, so libuv is managing all this work behind the scenes. But how does Node decide which completed task to run next? To understand that, we have to take a look at the event loop itself. You can think of the event loop as a constant cycle with a few key stops, or phases. For our purposes, these 3 are the big ones. First, it stops at the timers phase to see if any setTimeout or setInterval callbacks are ready to run. Then it moves to the poll phase. This is where it handles I/O events, like a network request finishing. And finally, it pops over to the check phase, which is where it runs setImmediate callbacks, and it just keeps going round and round this loop. This brings us to a classic Node.js interview question. Which runs first, setTimeout with a 0 delay or setImmediate? And now you know the answer is, it depends. It's not a trick question. Since setTimeout is in the timers phase and setImmediate is in the check phase later in the loop, their order isn't strictly guaranteed. It can change depending on how busy the process is when the code is first run. But hold on, there's another crucial piece to this puzzle. It turns out there's a kind of secret VIP queue that can cut in front of everything else in the loop. These are called microtasks. The best way to think about them is like an urgent sticky note the chef leaves for themselves. After they finish one block of code, before they even think about starting the next phase of the event loop, they stop and immediately process everything on the microtask list. It's an express lane that gets cleared out right away no matter what. And this VIP lane actually has 2 sections. The process.nextTick queue is like the ultra-platinum, highest priority section. Everything in there runs first. Once that's empty, the promises queue runs. So the exact order is always finish the current synchronous code, then clear out all the next tick tasks, then clear out all the promise tasks. Only after all of that is done does the event loop finally get to move on to its next phase, like timers or poll.
All right, we've gathered all the clues. We know about the single thread, libuv, the loop phases, and the microtask fastlane. It is time to finally solve our puzzle and understand the #1 rule of writing good Node.js code. Okay, back to our original puzzle. Looking at this with our new knowledge, the execution order should start to make a lot more sense. Let's trace it together. Here we go. First, the JavaScript engine rips through all the synchronous code, no waiting. So we immediately get start and end. But before the event loop can even begin, it has to clear out those microtask queues. Highest priority goes to process.nextTick, so nextTick prints out. Then it handles the promise microtask, printing promise. Now the microtasks are all done and the event loop can finally start its first lap. It enters the timers phase, sees our setTimeout is ready, and prints timeout 0. Finally, it continues around the loop through the poll phase and lands in the check phase, where it executes setImmediate and prints immediate. And there you have it. The puzzle is solved. And all of this leads us to the cardinal sin of Node.js. Because all of your JavaScript runs on that one main thread, if you give it a heavy synchronous task, like a giant for loop or a complex calculation, you're blocking everything. The chef is completely absorbed in one complicated recipe, and the whole restaurant grinds to a halt. No new requests can be handled, no timers can fire, your app just freezes, dead in the water. So what do we do when we have to do some heavy lifting? The modern answer is built right in, worker threads. This is literally like hiring another chef to work in a separate kitchen. You can hand off a CPU-intensive task to a worker thread, it'll churn away on it in the background, and your main event loop stays completely free and responsive to handle user requests. It's the best of both worlds. Okay, let's boil this all down to some simple rules to live by. For big files, use streams so you don't load everything into memory. For those heavy math problems, use worker threads. The golden rule is to always keep the tasks on your main event loop short and sweet. And of course, lean on promises and async/await. They use that microtask queue we talked about to help you write clean, non-blocking code. You see, understanding the event loop isn't just about passing a job interview. It's a mental model that will fundamentally change the way you write Node.js code. It's the difference between an app that scales beautifully and one that just falls over under pressure. So I'll leave you with this question. Now that you've seen the machine, how will you build your next application differently? Thanks for watching.